Welcome back to the powerhouse with your mathematical meathead himself, this guy. Let's talk about surface area a little bit more. Let's dive into some problems. Stuff you'll see on a homework, stuff you'll see on a quiz. Let's just dive right into it. We've already talked about the idea that surface area of 3D objects is nothing more than the addition of several different area calculations for such an object, which we can more easily see when we unfold it into a net. So let's work this out here. Let's look at this problem. This here is a rectangular, I'll write this down here, right? It is a rectangular rectangular prism. Well, we know it's a rectangle because look at this here. This is right, this. That is a rectangle. But we know it's a prism because all the all the how do I describe this? Basically, all the sides are either like some sort of box-like manner. Could be squares, could be longer rectangles, whatever the case. That's the clue that you're working with a prism. Usually, you'll have two different faces. In this case, a square here, which I'll call the face, square here on the other side. So two faces surrounded by box-like objects, in this case, four different rectangles. And actually, as a matter of fact, since I'm going to work this problem, what I like to do, I don't necessarily fold it out into its net. I'm not the best artist here, but I like to at least draw out the shapes that I know I'm working with because it just helps you keep better accountability of it. Let's see. Yeah, there's four. There's there's two squares, four rectangles. A neat little trick to figuring out, like for me, it's hard to look at a 3D shape and see it, but if I know the 2D face, for example, these squares, and I know how many sides there are of this 2D shape, so example one, two, three, four, then I know that's the number of other objects that are there, right? One, two, three, four. Neat little trick. If it helps you out, happy to know that it does. But listen here. So this is how I like to start my problems here. Draw it out. Okay, I see here the problem is giving us 3 as, and 3 is this here. I hope you can, maybe I'll do a different color here. The 3. No, actually, I'll even do even different color than that. A 3 here. 3. So that's what this problem is telling us. And then, well, one, we know this is a square, but also on this side here, it tells us that the height is 3 as well. So I know my squares are 3 by 3. So I could even write it 3, 3, 3, 3. Okay, makes sense to me. Now, let's see, I got my four rectangles here that I'm working with here. Well, this right here is telling me that the long side is 7. So I can even write that right here, right now. And then you can kind of see once again on this side, again, it's kind of like a little trick of the eyeballs here, but you can, the way that you're looking at it, you can tell that the short side of the rectangle here, right, that's 3 tall, 3 tall, right? So that's the dimensions of all of my rectangles. So now at this point we are adept at being able to calculate areas of 2D shapes. Right, we know how to do squares. It's side times side. So I'll do square. Actually, let me do a different color as well. Once again, visual variety here. Okay, squares. So I know my squares. Well, I like to set it up like this. I know I have two of them, and I know that let me say that even more clearly. I have two squares that are the exact same dimensions. In other words, and also these are my faces too. Your faces are always going to be the same exact dimensions. But here in this case, square is my face. I have 2. I like to set it up like this: 2 times side times side. Or you can even do, instead of the word side, length times width. Whatever word you want to use, it's up to you. But so with that idea or that knowledge there, okay, let's do this here. 2, put in 1. I'll put in one of the sides here times another one of the sides. There we go. So I know both of my squares, the area of all of my squares here is 3 times 3 right here. 3 times 3 is 9, and then distribute the 2 to that 9. So altogether, that's 18. If you want to be more precise, the units on that would be miles squared. I wouldn't necessarily ding you on lack of units. At this point, I'm more concerned that you can deduce what the number is. But in any case, got my squares. Now let's talk about our rectangles. Well, oh, wait a second. I forgot to draw all of my dimensions here. That's a 3, that's a 7, that's a 7, and that's a 7. Again, from this diagram, they're all the same. Anyways, so rectangles. Well, I know I have 4 the exact same, so I'll set it up very similar. 4 times something. Rectangles and squares, the way you calculate the area, same thing, side by side times side, length times width. I'll use length times width, but I'll even just use 2 letters for brevity's sake. Okay, so let's start plugging in some numbers based on this drawing here. I still have my 4 times, and then I'm going to say my length. I like to think of my length as being the long side, L. So my long is the 7 here, 7 times. And then I like to think of my other side or my other dimension, my width, as being the short side. So that's 3, so times 3. That is 4 times. 7 times 3 is 21. Distribute the 4, multiply, whatever you want to call it. That comes out to be 84. Again, I won't ding you on units, but correctly speaking, these would be the units. Okay, I've accounted for all of my sides, all of my 6 shapes. I've got 2 here, 4 here, 2 plus 4 is 6, 1, 2, or 2 plus 4 is 6, and then I got my 1, 2, 3, 4, 5, 6. So I only have 6 total, which is great because now I can just add these 2 up. Now I can just add these 2 up, get a number, and then that's the answer. So here am I'm going to add this right here, and I'm going to add this right here. 18 plus 84 comes out to be, let's see, scratch pad math this one real quick here. Not good at the mental math, but that's why we're here on this channel, to build up our mental muscles. Anyways, so 2, 1, let's see, 9, 10, 102, 102, there we go. So if you were to have this problem on your homework in a quiz or anything, you should say, aha, I know that the total area, I'll use the word or the letter A to represent area, but it's more correct to say surface area. So you'll see sometimes SA just means surface area. And when you hear the word surface area, you know it's all the sides of a 3D shape. But anyway, surface area is 18 plus 84, which I said earlier is 102. That's the answer. Fun, right? Not too bad. The key here is breaking it down, breaking the 3D object down into its component shapes. Let's go to another one here. Pyramids. Pyramids. You'll see pyramids. I'm going to give you pyramids on your homeworks and your quizzes, and don't be intimidated by them. The diagrams sometimes can be hard to see, especially triangular pyramids. This one is not triangular pyramid, but so I will avoid giving you triangular. I can't, like I said, it's hard for me to even see when I see such a diagram to see, the different measurements and stuff. So I will typically give you squares and rectangles. Just a little preview there. So anyways, I'll write this down once again. We know it's a pyramid. I mean, think of the pyramids in Egypt. We know that they kind of look like this, right? But we also more correctly name it by its base shape, which we can tell here is a square pyramid, right? The reason we know it's a square, a couple of reasons why. One, we have these 90-degree things here, little symbols on each corner. That's one way to know it's a square. Um, but mostly we deduce that from the measurement of the two sides, or at least two sides, right? They're the same, so therefore it's a square. So anyways, square pyramid. So when you unfold this into its component shapes, what you will see is you will have one square. Pretend that's a square, even though it looks more like a rectangle. And I see, again, the little tip I showed you is 1, 2, 3, 4 sides. That means the next object, there will be 4 of them. And pyramids, all the sides are always triangular. That's just the nature of a pyramid. All right, so I got 1, 2, 3, 4. There you go. So, problem is giving us, let's see, let's do gray. Why not? Problem is telling us right away that this square base is 6 by 6. So if I want, I can even, before I even look at the triangles, I can already just go ahead and start building out my little equation like I've demonstrated to you on the prism example here. I have 1 square. You don't have to write the 1 times, but I would, just to make it more clear. Anyways, 1 times, and we said again, a square, a rectangle, length times width, L times W. So 1 times 6 and 6 equals 1 times 36 equals 36. And again, units matter, but I won't ding you on it. Meters squared. Nice, I already know my square. Now I'm uh, close to finishing this one out here. I just got to dissect my triangles a little bit from this drawing here. Well, you can tell from the diagram, like if you look at, I'm looking at this one right here, this triangle here on the side. If you can follow along with me there. Okay, so I can tell right away that the base of that triangle is 6. Makes sense because each of these triangles is connected to the square. So that kind of makes sense, and just intuitively. Now this here, well, this here is called a slant height of the pyramid, but it's the height of the triangle. The height of the triangle, right? So 9.5. Now we've done, once again, areas of 2D shapes. We know intuitively that the area of a triangle is 1/2 times base times height. And I'll make it a little more clear here. We're saying our base is 6 and our height is 9.5. Okay, that's it. They're all the same now. Looking at the diagram, they're all the same sort of triangle. So all the bases and heights are the same for each triangle. I won't list them out here. Well, maybe I will. 6, 6, 6, and 9.5, 9.5, 9.5. There's four of them. They're all the same dimensions. So I'll do triangle, just like I did before with my square. Build out my partial equation here. I know I have four of them. And the 2D area of a triangle itself, as I said, is that. So inside of here, I'm going to write 1/2 times b for base. And it kind of looks like a 6. Base. There we go. Hopefully that's better. Base times height. Well, as I said, right, we know the base and the height, and therefore that makes every term here a number, which then, if they're all numbers, we can get a final number. So 1/2, and this is plugging in, right, the base 6 and the height, which I've said was 9.5 based on the diagram. So let's work inside and build outside. Inside, we're saying 9.5 times 6. 9.5 times 6. Well, if you do the math on that, where's my pen? There it is. If you do the math on that, you will see that these two multiply to give you 57. You can't forget about that 1/2 still there, right? That 1/2 just means you're multiplying by 1/2, or dividing by 2, right? So 57 divide 2 is 28.5, which again you can do that off to the side, a calculator, or even just work it out, like this, old school, long division. But it's 28.5. So again, I can't forget about my 4. You don't want to forget about that out there. But 28.5. Then take that, multiply it by 4 to get a result. Your result then would be 114, 114, and of course units, units, units. So I have two answers. Or actually, wait, well, I've accounted for all of my shapes, I got my one square here, and I've got my 4 triangles here. And I'm saying that I got one square, and then 1, 2, 3, 4. So 5 total shapes. I've accounted for 5 shapes here in my little equation that I've built out. I'm ready to wrap this one up here. I'm ready to wrap this one up here. So 114 plus 36. I'm going to scroll down just a little bit here and show the final step. Surface area, once again, SA, surface area equals 36 plus 114. It comes out to be, let's see, I need more room here. Run out of room, there we go. Let's see, 150, there we go. Again, sometimes even I have to do scratch pad math. But it's 150. 150. 50 meters squared. Boom, that's your area, or that is your surface area. That is the answer to the problem. That was kind of fun, right? Not too bad. Again, the key, break it down into its component shapes. Now cylinders, this is, oh yeah, cylinders right here. Yeah, it's actually technically a prism, but it's most commonly referred to as a cylinder. Cylinder, or, if you want, prism, or even circular prism. But in any case, you saw in the last video, we unfolded such an object, such as maybe a soup can. We cut it, down in a pair of scissors. We cut it, we unfolded it. It ended up looking something like this. You got your two circles, right? Circle one from here on this side, circle from this side. So I got two circles that are the same. And then again, when you cut it down the side like this, and you unroll it, think of a roll of toilet paper. The paper itself isn't round. It rolls out flat, and that's exactly what happens to cylinders. So we have just one long, flat rectangle. Okay, all right, not too bad. Only three things to work with. Not too bad at all. I'll kind of set the stage here. I know I'm going to have circles, and I know I'm going to have rectangles. And I can see visually that I'll have 2 and 1. All right, I kind of set the stage. Let's draw what we know. So we're saying this long, actually the short side, right? If you cut this way, this is the short side, and you unroll, it goes all the way around. That's the long side. Kind of hard to draw it here like this, but this is saying that it's the short side of this rectangle. So I got 6. Now, how do you figure out the long side? You kind of have to, most of the time, they're not going to outright give it to you. But the little trick to realize that is the long side is actually the diameter of your circle. Most of the time, it'll just give you a radius. There might be few where it gives you the diameter, but understand most often you're going to get a radius value in the diagram, which it's 4. So a radius is simply half of a diameter. So 4 plus 4, 8. That is our long side, 8. Makes sense that this would be considered the long side because this number is, or it would make sense that it's 8 because 8 is bigger than 6, and we're saying 8 is our long side, which means it has to be bigger than that. Either way, you should feel rest assured that we've done it correctly. Again, if you want experiments at home a little bit, cut up a soup can. You'll see. Anyways, so we got 6 and 8. Okay, nice. Let's do our circles here. Well, you can tell, well, the only thing you really need in what the diagram does offer is really just the radius, or if they give you diameter, great too. So it's saying that it's 4. Saying that it's 4. Perfect. Well, with a circle, I'll do it here inside the actual equation, right? We're saying that the area of a circle, we know this from before, is pi, which itself is just a symbol for a very unique letter or a number in the world, right? 3.14, blah, 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 blah. It just looks like not a number, but it really is. So pi, and then r for radius. This is our radius. And then squared. Squared meaning multiply the radius by itself 2 times, get a value. So that is the formula. So A equals pi r squared. That's the formula for the area of a circle. And I just wrote it here. We have all of our values now, right? If we, the only thing we need is, because we know this is a number, and we really only have one unknown number here, that's the radius. It's given to us. Boom, we can solve. So let's do so. So my 2 from the outside, pi, and then radius, which I'm going to put the 4 in its place. So again, work inner and outer. This here is saying I'm starting with the parentheses and exponent on the outside of that parenthesis. Right, 4 times, let's raise to the power 2. It's saying 4 times 4, basically. So 4 times 4, you work that out. That is 16. And here's what you got. Now, 2 times 16 times pi. Well, you can simply distribute the 2 here to get 32. And I'm going to leave things in terms of pi. You can, take it to the next level and do 32 times 3.14, blah, 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 get a number. In most higher level math, you won't really ever do that. You'll always really just have your answers in terms of pi, which means that just worry about the numbers, leave pi alone, but don't forget about it, but leave it alone. And of course, if you wanted to be correct about the units, yards squared. Makes sense. It's actually the hardest one. That circle of the area is the hardest one out of a cylinder sort of problem like that. Just, I know, right? Because rectangles are so easy. Now we know them. We're so good at them now, right? Length times width. That's the formula. We're saying length, long side is 8. Saying short side, the width is 6. 8 times 6, 48. 1 times 48 equals simply just 48. Once again, yards squared. Okay, let's see here. I got 1, 2, 3 shapes. I'm saying I got 2 of these, 1 of these. I've accounted for 3 different objects here. Just add them up, and there you go. So 32 plus, oh, that was a little sloppy there, but you get the point, right? 32 plus 48. 32. So final answer, drum roll. 32 plus 48 equals 80. 80 yards. That's right, yards squared. 80 yards squared, guys. Actually, is it? Let me just double check that. Let's see. 48 plus 32. Yeah, it's 80, of course. Anyways, that is the answer. I hope you found this video informative. I hope it has pumped up your mental muscles. And see you next time, guys.